I'm Brandon Lewis, and I'm here with Christopher Main, who is the president, founder, and chief technology officer at TenAsys. How are you doing, Christopher?
Doing very well, thank you, Brandon. How are you?
I'm doing well, thank you. So, embedded engineering has changed a lot since TenAsys was founded, more than 25 years ago now. How have you seen the change in the industry, and what's the same and what's different?
Well, at that time, we were emerging from a time where your control systems were custom designed hardware and software, and people were beginning to adopt the PC and the Windows operating system, primarily because of the wealth of software available on Windows, and PCs were becoming ubiquitous. And Windows finally deemed to be reliable enough to support an application that might run for more than a day. um, we This was the time of single core CPUs, so it was a bit of magic where we were able to run our real-time operating system at the same time as Windows was running on this PC, and we were using the real-time operating system to provide control capabilities, so somebody could build, for example, a PLC with a programmable front end and then a real-time engine on the back end to do the control. Prior to that, we used to talk about the two-box solution, where you'd have a general purpose PC with a nice interface and something running like QNX or something like that, or even RMX from Intel on custom hardware to do the control. And the idea was we can do this on one PC and allow you to do what you need to do and throw away one of your computers and one
So
of your
this is
developers.
so this is really like virtualization and workload consolidation before those were things, right?
Absolutely, yeah. So you look at some of Intel's presentations or other people's presentations now. They got the right slides we had 25 years ago.
So
Obviously, things have changed since then. So there's been other developments in the meantime. Multi-core CPUs, that was a really interesting one. So we were, can't remember which exhibition. At an exhibition, Intel had invited us there. We had an early application showing we could run our real-time operating system on one core and Windows on another core. And they were touting this multi-core, two-core capability. And there was a interesting that a senior scientist from, I think, Siemens or one of those big automation companies came up to the booth and asking the Intel people, does that mean I can run one operating system on one core and one on another one? And they said, come around the corner and meet our friends from TenAsys. And we were doing exactly that. I can't remember what the application was, but it was exactly that. And suddenly people were able to understand what we were doing after 4 years in the market. So how do you do two things with one core? Oh, you got two cores. Oh, well, it's obvious. So there we go.
So since then, obviously a lot has changed. I mean, I
Mm-hmm.
don't even know if you can get a single core CPU from Intel anymore.
I was going to say there's been other developments, obviously. It's not just the multi-core. Intel
Of course.
introduced the hypervisor technology, which we were really excited about. We thought we can really do something with this, and did it for a while. In the meantime, there's other people who've concentrated on that technology, and we've backed away a little bit. But we're now working with those partners to take advantage of that technology, because what it does is it makes it easier for you to consolidate not just two workloads but multiple workloads, and isolate those workloads not just for performance but for security and reliability as well. So the development of the hypervisor has been really important in this space. Many spaces, but it's just coming to this space too. Yeah.
Well, it's a real big testament. I mean, number one, the vision, right, to be able to get into that niche before it actually even really existed, right?
Mm-hmm.
But then, too, I mean, here we are, decades later, and TenAsys is still leading edge. How have you been able to evolve with the dynamic requirements of your customers over, the last 20 plus years?
Well, part of it's looking at how the landscape was changing. I mean, there was a big change in the way I/O was driven, which we can go into. But listening to our customers what they want to do. Some of our customers have, quite forward-looking things, so we're very interested in keeping up to date with where they think they need to go, and helping them get there or explaining why they need to do a different thing. Trying to provide core technology that allows them to do what they need to do. So, for example, this I/O shift I was just referring to. In the old days, when you had a custom controller board plugged into your PC with specialist cables connected to your I/O device for vast price, not very many manufacturers able to participate in that. It gradually shifted to your connection was standard Ethernet. So we were able to provide Ethernet software to allow people to connect to whatever the devices on the other end were, whether it was technologies like EtherCAT or Profinet and so on. We were able to provide some basic software to allow people to develop those stacks on top in a way that it provided the appropriate performance. One of the significant things is being very deterministic at when a packet is transmitted to these devices, and we made some modifications to Ethernet software to enable that to be incredibly precise. And that was very popular as these Ethernet-based technologies for I/O took off. We had worked with some partners who based their I/O stacks on InTime and this Ethernet technology, to individual customers who are able to implement their own things without having to buy third-party solutions, particularly in the EtherCAT area. That was very easy. So we were really ready to look for the next shift that was going to happen in that area, and that became clear about 5 years ago. Was going to be TSN.
Yes. So TSN, obviously you guys were already headed down this path, and I don't know if 5 years ago is accurate, because man, this thing has been going for 10 plus years now, right? This
Right.
TSN standards. But the promise there is immense, right? You mentioned
Yep.
EtherCAT, Profibus, all the other deterministic flavors of industrial Ethernet. The promise of TSN is that we can bring those all under one roof, and from the network perspective, we can accommodate them all. Is that correct?
Right. So there's two things happening. One is, yes, all these different standards are proprietary, and some manufacturers decided to use the TSN standards to say, look, we're now using a standard. It's not proprietary. And they're using TSN like they use their proprietary standard to provide deterministic I/O access and so on. But that's all it is. It's a standardized access to their I/O. You don't get to share the network, at least not very easily, at least at this time. Whereas where we see TSN going is more, it's enabling converged networking, where multiple applications are able to share the same network, not just the same platform, or multiple applications on multiple controllers are able to share access to multiple devices across the same network. So TSN allows you to do that because you can configure multiple applications to use the same network. They have their own bandwidth requirements and timing constrictions and so on, and that can all be designed into the configuration of a TSN enabled network.
I was going to ask, besides getting locked into, a specific vendor's flavor of Ethernet, why would anybody care about TSN, right? And then you proceeded to answer, well, they'd be interested in TSN because we've got this convergent network. But then the next question is, why do I care? Why does anybody care about having a converged network or the ability to have these distributed applications? And what is this going to enable for us in the future?
Well, converged networking is a stepping stone into some big initiatives in the industry, one of which is the further development of Industry 4.0, smart manufacturing, the ability to reconfigure your network in software as opposed to sending your technician down to rewire your factory is a big plus, in my opinion. tilting everything towards software instead of continuously changing your hardware and changing the wires and so on. And the even more exciting one is the step towards what's called software-defined manufacturing. This is an initiative that came out of software-defined networking, but it's being applied to the manufacturing sector. That it's to do with the design, configuration, and integration of a complete manufacturing facility, a factory, all connected all the way back to the IT side of things as well, where you can design and simulate your whole factory first and then turn that into your real factory just by applying that configuration to your real set of hardware.
That's
And
great.
that has huge implications for the way that factories operate and run and how efficient they can be and so on and so forth.
So how does the TenAsys portfolio come into play here, right? So obviously you have in-time, real-time operating system, and complementary tools and infrastructure that you have to support that RTOS. But what does an RTOS have to do with, or real-time software in general, have to do with TSN?
Well, the applications that you're supporting on a TSN network will involve some control, and that requires a real-time operating system at the controller end in order to be deterministic, service the inputs, provide the outputs as designed, and not to vary. And that's what your real-time operating system's for. If your real-time operating system is going to operate over a TSN network, we have to provide the fundamental infrastructure to allow you to interface to that network, which means providing the scheduling, the configuration, and synchronization that you need in order that's required in order to do that.
So when you start talking about the combination of TSN, workload consolidation, I mean, you have a couple of pretty significant building blocks that are pretty fundamental to, the fabric of who TenAsys is, that are,
Mhm.
like you said, stepping stones towards this software-defined manufacturing future, right? Would you agree with
Right.
that statement?
Absolutely. I mean, if you imagine today's, a corner of a factory today, which has 8 controllers connected to 40 motors, each of which divided into 8 separate machines. If you look into the future there, you can imagine like a server platform with 8 virtual PLCs on there connected through a converged network to your 40 motors in different combinations, depending on what it is you want to manufacture or what it is you want these machines to do. That's the vision, and that's the way forwards that people are talking about in this market.
So you've got these pillars. Obviously, the next step is to take these pillars from being abstract concepts and start putting them into actual working proof of concepts. And I know that you've done that. So can you explain a little bit about some of the demos and reference designs that you've been working on and how they capture some of the capabilities of TSN?
Okay, for example, at an embedded world coming up in April, we've developed a concept demonstration to illustrate our ideas about TSN. It's showing 3 things. One is that we can support multiple applications on a converged network. Secondly, we're showing an existing application based on Profinet, showing that you can adapt it fairly simply in order to operate over a TSN compared to its original OT connectivity without too much effort. And this is going to be important in the adoption of TSN in the market. And thirdly, it illustrates our concept of how the TSN interface is presented to the developer, that we're hiding all the complexity and just revealing the resources that are required by the developer in such a way that they can pick them up and use them in order to realize their application.
Now, I'm sure you'd like to take credit for doing this all your own, but there's no TSN stack or TSN demo out
Right.
there that's built on one vendor's component. So, what are your
Absolutely
technology
not.
partner components that are in there? What's the technical content that you've gotten from partners?
Okay. Most of this development we've been doing in association with the ISW Institute and the University of Stuttgart. They have a group that's very focused on TSN, especially in automation, um, and has been driving some of the adoption of TSN and so on. And they helped us develop the software model that we're presenting here. Very knowledgeable people, got great ear to the ground in the industry, so very valuable partner to deal with here. The key component in any TSN implementation is PTP. PTP, the Precision Time Protocol, is what synchronizes everything in a TSN network. And when I say everything, I mean absolutely everything. Everything connected to a wire has to be synchronized to within less than a microsecond in order for TSN to work at all. And we, rather than develop our own P2P solution, are working with a partner called TSEP, German company who've been in this P2P, been providing P2P solutions for a long time, have a lot of expertise we've been able to draw on. And then we've got some hardware partners as well in our demonstration. Contron is known as providing TSN-enabled hardware components. We're using some of their switches in this demonstration. And of course, Intel in their silicon has provided TSN features in their network controllers that we're using in this, and also within the CPUs in this TCC initiative, allowing the CPU to behave in a real-time deterministic way all the time, that is essential in the sort of application that we're talking about.
So, Intel Time Coordinated Computing does a really good job of providing out of that hardware enablement and then also software tools that higher level technologies like InTime can take advantage of, and then really abstract away all the complexity of these underlying synchronization between all of these various endpoints, et cetera, and really just focus on application development, which is really great towards, as you said, enabling adoption of TSN in the market. Now, you also mentioned a big stack there. There were 4 or 5 different suppliers there in addition to TenAsys. Do you think with that stack, with all that infrastructure, that we are at a point where in the not too distant future, we can start to realize some of the benefits and advantages of software-defined manufacturing?
Yes, I think that stack is certainly providing a big step forwards on the production side of SDM. There's also other components required on the simulation configuration side, which are also present today. And we have partners that we work with who are active on that area as well. So yes, I think there's a good ecosystem developing that's going to be able to bring this to fruition.
Given the fact that we've got all of this at our disposal now, what's the future? What's next for TenAsys and its partners moving forward in TSN?
Well, we've come a long way. We've managed to produce, a proof of concept demonstration. We need to continue to work with our customers and partners as these ideas continue to be adopted and understand where the real use cases are going to be. There's a couple of obvious ones emerging at the moment. For example, the OPC UA initiative has got some very well-defined uses of TSN within it, but that's just one application. There's going to be many more. We're going to continue to follow our customers' requirements and exploit our partners' knowledge and experience in order that we can continue to lead this initiative and provide effective solutions to the market.
Well, thank you so much, Christopher. Really appreciate your knowledge and experience, and then helping us view this picture of where the next generation of connected embedded computing is going to be, or whatever we're calling it at that point. If you'd like to find out more about TenAsys, what's work in time-sensitive networking, workload consolidation, real-time computing in general, you can find them at Embedded World in Hall 4, stand 458, or if you're looking for resources on TSN and other elements of embedded development, there is a wealth of resources on the TenAsys website, which you can find at www.tenasys.com.
including a link to my presentation.